So Tuesday we were discussing lists and we mentioned dictionaries. We will continue to do so. What is a list? It's just a sequence of data pieces, right? Like that. Except without that square brace. Right, there we go. And we can add them together. A equals sum of A, and then if we print out A, well, that was dumb. I erased my list now and stored a total of it instead, so it's no longer a list, but it's anyways. So we got the sum of the list by doing that. Normally you would not take that variable and then use it again to hold the result. Or it could be a list of names or words or whatever we needed to store a tally of, we could put in there. Once you create a list, you can check to see if something's in the list or not. Is Joe in the list? Joe in the list? Yeah, sure is. Is Fred in the list? It is false. What if you want to find the exact position of something in a list? You want to find out that Sam is at position 1. Well, we can do that. The same kind of things work in strings as well, right? If we have a string here, like if your string is, Johnny, and we want to find out whether there's an M in there, we could find out, right? M in A, or not. M in A, right? And there we go. There are no M's in that. And by the way, that would be applicable to the hangman game, right? To guess a letter, is that letter in the string? Something like that. All right. If you need a list that is a range of values, you can use the range function to return a range of values which you can then convert into a list. So if we want a list that is all the numbers between 100 and 200, well, list parentheses range parentheses 100 comma 201 would give us that list. Now I should have stored a variable for processing, right? But L is equal to list parentheses range parentheses and whatever our conditions are. We want to count from 10 to 100 by 10s, 10 comma 101 comma 10. Now we have a list. There's all the numbers between 10 and 100 that are divisible by 10. I can't say how often I ever felt the need to do that, because if I wanted a sequence of numbers, I would just use a range rather than a list. But the useful thing to notice is that there is, in fact, a list function, which will take something and turn it into a list. And it's not that it's really a function, and it's a data type. Just like the dictionary is a data type, just like INT is a data type. That's how we were always able to do things like this. I is equal to INT, and then we typed in a number there, right? Like that. So the data type itself can be used to construct a piece of data. To add to a list, say we have this list up here, like that. We do have that. And now I'm scrolling at the bottom of the text, which I always hate doing. L plus equals, let's add a 200 onto the list. And it did not work, so why were they showing me that it would? I know that I can add a list to it, but I thought that they were showing. Oh, I see what they did. All right. So I have that list, and I want to add another element onto it. And now when I print out the list, it's got a new item on it. Now normally I'd use dot append. Or when I say normally, that's just how my brain thinks of it, right? I have just added 300 to the list, but the concatenation operator works just as well. You concatenate that list. And you can concatenate two lists together. If list 1 looks like this, 1, 2, 3, and list 2 looks like this, 9, 8, 7, then you can build a list that is a combination of those. C is equal to A plus B. So if we print out C, we see it's got 1, 2, 3, 9, 8, 7 in it. So to print the contents of the list, you can just print out the list variable. Right, print C, sure, it'll print it out. Or you could write a for loop that'll print it. For E, short for element, in C, colon, print parentheses E, and there are printed them all. And we could get fancier with that, right? We could use the end parameter to put them all on one line rather than one after the other. Or lastly, you could use the join parameter, or the join function. Something like this. Print parentheses, I want everything in here to be separated by a comma followed by a space. So quote, comma followed by a space, end quote, dot join, and then pass that list in. Join C. And then a closing parentheses. When I do that, oh well, what did I do wrong? Sequence item, expected a string instance, found in end. Okay. Valuable lesson learned. You cannot use join unless it's a list of strings. Well, what if I wanted to make that a list of strings? I keep mentioning list comprehension. List comprehension is just using list notation like this, but instead of putting a value in there, you put effectively a for loop expression in there. Something like this. And I'd actually have this in a program so y'all could be typing along with me. String x for x in C. So for every value in that list, convert it to a string and store it back into that list. And now it's a list of strings, whereas before it was a list of numbers. How do we know that? Because I've got double quotes around it. And now that dot join business would work. Right? I want to see this data all separated pretty. For some reason I want question marks between everything. I can do that. So are we on S? All right, so I'm going to just give some more demonstrations of that kind of stuff, but put it in the Python file for future keeping. So that's an empty list. Now I'm going to add some items to it. N.append, Fred, N.append, Joe, N.append, Sue. Now let's make a list that is the joined version of all that. No, we're not going to make a list. We're going to make a string that is a joined version of all that so we can print it out. S is equal to, and I want everything in here to be separated by commas followed by a space. Nah, no space. So S equals quote, comma, quote, dot, join, parentheses, in. Take that in list, join them all together, putting commas between them and stored in S, which we could then print out. And that's in fact what it did. Printing it out, one per line for E in space in colon print E. That'll print out every element in the list. So a list is mutable, unlike strings, meaning that the elements can be changed. If you have this list here, items 0, 1, 2, and 3, well, element 3 right now is equal to a 4, right? 0, 1, 2, 3. But if we do this, element 3 is equal to 0, then the next time we print it out, it'll be 1, 2, 3, 0. So the subscript, the index, references the target of the assignment, which is a position within it to change. Here is an example of using a for loop to change everything in a list to uppercase. Or we could do that with list comprehension. Here's how it would look with a for loop. We already have a list of words here. So instead, rather than do this, well, let me take a peek. When I've been showing you this, you can also print them out by their index rather than the actual value, right? This is the actual value. Well, it's a copy of the value of every element in the list. But you can do it by indices as well because, right, if we did print in subscript 0, we know that it's going to print Fred. If we do print in subscript 1, it's going to print Joe. In subscript 2, it's going to print Sue. So why not use a for loop, a for range, to get those values? So for I space in space range, parentheses len of the list, len, parentheses in, then two close parentheses and a colon. Print the list, print parentheses in subscript I, in subscript in parentheses. And we could use that same syntax to do something to every element in the list, like convert it to uppercase. For I in range, parentheses len, parentheses in, two close parentheses and a colon, in subscript I equals, in subscript I dot upper. We want the uppercase version of it. Now, if we wanted to use list comprehension for the same thing, it would look like this. N equals square brace E dot upper parentheses in parentheses for E in I in space in. I wish I chose a different variable name other than in, because when I say in, it sounds weird. All right. These two things do the exact same thing. I'm fonder of this syntax. However, if you've seen for loops a lot and haven't seen this much, then you can be just as fond of this one. So several methods. Dot append, we've seen. Dot extend, which is the same thing as dot append, except you are giving it an entire new list to tack onto the end of it. Like this. We already have a string of names up here. We could have another list of names. N2 is equal to whatever. Jeff, Eric, Jill, like that. And then we could append that one to this one, except we're not appending. So n.extend with the contents of n2, n.extend n2. Now if we print out n, it's all 6 of those items. Then there's the insert method. Insert allows you to put something into a specific position. If I want to insert something to the beginning of our list, I'd use index 0. I want George to be at the beginning of our new list. So into.insert into position 0, comma, quote, George, end quote, in parentheses. And now I'm going to insert another one, but I want it to become the new position 2, not the new position 0. This puts it at the beginning of the list. So into.insert 2, comma, two. The only reason I'm doing that is so that it'll kind of stick out like a sore thumb when we print it out. Print into. That string that I specified inserting is now the new subscript 2, right? 0, 1, and 2. I'm seeing something odd that I'm not understanding. What happened to Joe? What happened to Sue? Oh, let me guess. I'm doing all this with in2 rather than in, so here's my cute little list of names, and then I kind of ignored it. I'm going to just change those to in so that I see what I'm expecting to see. Always choose better variable names, no single letter variable names like I'm doing. All right, and there we go. Right, George got inserted into position 0, so it's the new position 0. This word got inserted into position 2, so it's the new subscript 2, 0, 1, 2. Pop takes the last item off the list. So if I want to get the last volume and the last element and remove it, I could do that. Well, I sure have a lot of names on here, so names is equal to n.pop removes the last item and returns it. So now if I print out in again, it's going to be one element shorter. I think I'm going to make this name singular because there's only one name that we're popping. Or you can specify a position. You want to pop the first thing off the list rather than the last one? You could do that. Name 2 is equal to, why don't we do this? How about last equals in.pop, that got us the last one, and then first equals in.pop at subscript 0.
You're supposed to be printing last instead of in?
Yes, well, good point. I'm going to delete that. I'm going to move print in to here. And then I'm going to, so print parentheses in, and I'm going to do print first, comma last. Because I want us to see what the list looks like after the 2 poppings. And so, Fred, 2, Joe, Sue, Jeff, Eric, all the contents of this list minus the front, first, and the last elements are there. And then the first element was George, and the last one is Joe. What happens if you pop an empty list? What do I mean by that? Well, I'm going to make an empty list. L is equal to that, and then I'm going to say x equals L dot pop. You're going to blow up. So you're going to say you don't have a, yep, you're popping from an empty list. What if we wanted to pop every single element of the list off? In that case, we'd want to make sure that the list never falls below the length of 0. So while len parentheses in parentheses is greater than 0 colon print parentheses in dot pop in parentheses or parentheses in parentheses in parentheses. We're going to just pop every item off the entire list. The list is now empty at this point. So we're looping while the list is not empty, removing the last element. But it doesn't merely remove it. If we had stored it somewhere, we'd still have a copy of it, right? I could have done s is equal to n.pop, print s, something like that. S equals n.pop, parentheses in parentheses, and then in here, print s. So that removes and returns. But I still have that error that I put here. Get rid of those two lines. If you didn't see which ones I said to get rid of, it's those two, if you added those. All right, and so now our list is empty. And if we look at it, since it was popping them with no subscript, it was taking them off the end. So Eric was first, and then Jeff, and then Sue, and then Joe, and then 2, and then Fred. And then the list is empty. So just as a parenthetical, whoopsie, let's put some comments to the effect that l.append x appends x to l.insert 0, comma x inserts x into the beginning of the list. L.extend, parentheses L2, appends list L2 onto list L. L.pop removes and returns the last element of list L. L.pop parentheses 0 removes and returns the first element. Of list L. If x space in space L checks to see or is true if x is found in list L. Well, we've seen how to insert things, we've seen how to append, we've seen how to remove by using the .pop. What if we just wanted to delete an item? What if I had that list and I didn't like the fact that my own name was in it, so I wanted to have delete Jeff from it? Well, we can do that. You can use the index method to locate something in a list. Suppose I don't care whether Fred is merely in the list, but I want to know which position he is in. Then I can use the dot index method. But it blows up, it raises an error if that target element is not found. It's not quite ideal, which is why you precede it with an if statement. If the target is in the list, didn't do something with it, then you use .index to find it. Time to make a new list. Let's add that one on though. L.index parentheses x returns the index position of x in list L, but raises an error if x was not in L. So you use if x in L to prevent that error. So cars is equal to square brace, Ford end quote, Audi end quote, comma, Toyota end quote, comma, BMW. Now we have a list of 4 different cars. And for whatever purposes I want to find out the index number of Toyota. Say I was going to change it for something. For some reason. I is equal to cars, not fars, cars.index, parentheses, quote, Toyota, end, parentheses, end quote. Well, at this point, it's going to equal 2, 0, 1, 2. Because that is its position. So if we print it out, cars at subscript I, it should print out Toyota. And so it did. Now what if we misspelled it? What if we put a capital T in here, and since this is a lowercase t, it's not going to find it at all. Toyota is not in the list. So that is an inherently risky function, and what you would really want to do say we're looking for a VW in it. If, quote, VW in quote, in cars, colon, now we can get the position of it. I equals cars.index, parentheses, quote, VW, end quote, in parentheses. Print, parentheses, cars, subscript I. Now I'm back tabbing so that I can do else colon, print parentheses, quote, VW, not in cars list, end quote, in parentheses. Now this is kind of dumb, right? I should have put VW in a string rather than repeat it over and over and over here, right? But that's just to give the clearest example. A better example would be doing S equals VW if S in cars, print out the cars.index of S. I guess we may as well do that. S equals, quote, BMW, end quote. If S is found in that list, if S space in space cars, colon, I equals cars.index, parentheses S, and then we could do something with it. Print parentheses S, comma, quote, found at index, end quote, comma, I. Which it's not. Yeah, it is. Right, it's right there. But if I change BMW to something else, it's not going to print that. BMW was found in position 3, but not if I change it to capital B. So I'm going to add an if and else clause here. Else colon, print parentheses S quote, not found in cars list, end quote, in parentheses. All right, now we've typed for 30 minutes. It's about time for me to see if anybody wants help. All right, some changes that I threw in that may have slipped your notice is I commented that line out because otherwise it's giving you a syntax error. Or not a syntax error, it's giving you a runtime exception. And here, these variables change their names a few times. So if you run it and it says you don't have a first or you don't have a last or whatever, it's because of that. If you want to sort a list, you can use the .sort method. We could sort our cars. Cars equals cars .sort. Parentheses and parentheses. And then when we print them out, they should be alphabetized. Well, that goofed. Don't do cars equals cars.sort. Just do cars.sort. My mistake. I had to change that line. No cars equals in front of it. All right, and now the cars are sorted alphabetically. And that works for numbers as well as strings, as you would imagine. Well, this statement's extraordinarily wrong. Mutator methods, things that change the stack, the list, usually return no value of interest to the caller. So yeah, we're not going to store the result. We're not going to say x is equal to list.append. We're not going to say x is equal to list.insert. But pop, absolutely we want. That's one of the entire reasons that it exists, is to get and return the last value. So if I'd written this slide, I would not have done that. I would not have put that there. And they're just demonstrating the mistake that I made there, is if you do a list is equal to a list.sort, and then you print it out, it says none, because it didn't return anything. None is a special value that gets returned by functions that don't have the return keyword. Like if we do this, def test parentheses in parentheses colon print parentheses quote, this is a test in quote in parentheses. And then I do this, a equals test, parentheses in parentheses, and print out a. It's going to print none with a capital N. That's just a special value to say that function didn't return anything. And you could even check, right? If a equals none, colon, and we print test returned nothing. So it's like there is this invisible line at the end of every function that does not have a return. Return none. Like that's there. We don't have to put that there because it happens automatically. This always happens for functions with no return statement. So one thing you need to make sure that you're aware of is if you do something like this, we had that cars list, right? And then we do more is equal to cars. These are now pointing to the same memory. So if we make a change to one car list, it's going to also affect the other. It's like you have two street signs pointing to the same street. And then you go and paint the street red. Well, both street signs are now pointing to a street that's red. So if we do this, more dot append, and let's put some other kind of car on there, a Chevy. and then we print out cars, although we thought that more might be a copy of the cars list, they are actually the same list. So this change here is going to be reflected when we print that out. We will see Chevy at the end of our list. And so we did. The textbook calls that an alias. Other textbooks would call it a reference. More is an alias, parentheses, reference to the cars list, and points to the same place in memory. So when we append Chevy to the more list, it shows up when we print the cars list. So programmers might need to see whether two variables refer to the exact same object or to different objects. If you want to determine whether one variable is an alias for another, you can use equal. We could do if more equals cars. Unfortunately, equal also returns true if the contents are the same. The first relationship is called object identity, and the second one is called structural equivalence. And in this particular language, equal has no way of distinguishing between these two types of relationships. I'm not coming up with a good reason for us to dig in on that. That's just saying that if we do this, if more equals cars, print the same, it will print the same whether they point to the same list, like they do now, or whether they point to two separate lists with the same contents. So if more is an alias for the cars list, or if both are separate lists with the same content. But you can use the is keyword to check its identity. If more is cars, print parentheses, quote, same, end quote, parentheses, this only prints same if more is an alias for the cars list. You're just checking, are you the same object? And in this particular case, I guess let's make some examples. A is equal to subscript 1, 2, 3, and subscript, A equals square 1, 2, 3. B equals square brace 1, 2, 3, into brace. Print A equals B. This will print true because their contents are equal. Print A is B. That's not true. They are not aliases of each other. So a tuple, I've mentioned them once, twice, resembles a list, but it is immutable, meaning that you can't change it. Since we have fruits here, we could not say fruit subscript 0 is equal to orange and have it change. We could print out fruit subscript 0 and it would print out apple, but we can't change it, we can't pop, we can't insert, we can't append, we can't remove from it. Defining simple functions. I don't want to talk about functions right now. They've skipped two very important things with lists. How do you remove something from a list? Well, we've talked about .pop, but I guess that's one way of removing it, but there are others. What if you wanted to delete something by index? We have that cars list, but we want to remove the first thing from the list. Delete cars subscript 0. That takes the first element out of the list. Now sure, we could have used pop parentheses 0 to accomplish the same thing. If we print the cars list now, we'll find out that that item is missing. What if you don't know its index value? I know that BMW is in the list, but I don't remember where it is. Cars.remove, parentheses, quote, BMW. Searches the list for BMW and removes it. That's another one of those that'll generate an exception if it's not in the list. So when I run it, it doesn't give me an error. I can print the cars list out again and we would see, in fact, that BMW is gone from it. But if I change it to something that doesn't exist in it, Nissan. We're going to try to remove Nissan, and it's going to blow up, so I'm not going to keep this change there because Nissan is not in the list. So that's another one to come up. Scroll way up to our little list of important information. DEL, L subscript X deletes the item at index X from list L. L.remove, parentheses X, which is not its index number, so I'm wishing I hadn't used the same variable here. How about value? L remove value removes list, removes the item that matches value from the list. But will cause an error if value is not in the list. So again, you would use an if value in L check first. So we talked about dictionaries. Dictionaries are pairs of values, a key and a value. The key might be your name, the value that you're trying to retrieve might be your social security number. The key might be the fruit, and the name might be, the value might be the color of the fruit. So let's create an empty dictionary. I call it capital F for fruit. And you can create an empty dictionary using the data type dict, or you could just say F equals and then open curly brace and close curly brace. So these make empty dictionaries. And so now we can say that the fruit subscript quote apple end quote in subscript equals red. That apple is red. F subscript quote grape end quote in subscript equals, we've got green grapes. And F subscript quote berry end quote in subscript equals blue. Now if we want to find out if something is in there, we can do that. Let's get our input string for whichever fruit we want to find out the color of. So S is equal to quote grape. If space S space N space F colon print parentheses S comma quote is the color end quote comma F subscript S in subscript in parentheses. If it's not, we would get an error by trying to access it, so we could put an else saying that that fruit does not exist. So else colon print parentheses S comma does not exist. S comma does not exist in F. End quote in parentheses. So we could use dictionaries to keep track of counts. It's called a histogram. You're rolling a die. How many different times did you roll a 6? You want to keep track of that. Or you roll 2 dice. How many times did you roll a 7? Something like that. Well, let's do something like that. We're going to create a histogram using a dictionary, showing how many times we roll different values with dice. So let's import random so we can play with the random function. And I don't know, let's loop, 100 times. So for x in range, parentheses 100, we're going to need an empty dictionary to hold our dice values, our dice rolls. So above our for statement, how about we do rolls equals open curly brace, close curly brace, or if you like to use the word dict, D-I-C-T, parentheses like that. Empty dictionary. So let's get our die roll. Which is going to equal to random dot RENDINT 1 comma 6 in parentheses. And then let's get a second die that's just like that. D2 equal, and you could copy and paste faster than I'm typing it, random dot rand int 1 comma 6. Tell you what, I'm changing gears very, very, very slightly. We're going to make a list called roles first, and we're going to add all of our die rolls to that list. So I'm changing this line here. Roles equals that. And then we're going to process that list, building our dictionary from it. The way I was going to do it is we didn't have the original data anymore, and we might, want the original data. So we have, for x in range 100, d is equal to random dot rand int 1 comma 6, d2 equals random dot rand int 1 comma 6, and let's append to our roles dot append d plus d2. And we could print our list out for fun. Print our roles out. And we see all of our die rolls, right? According to probability, we will not see very many 2s, and we will not see very many 12s, and we're going to see a whole bunch of 7s. You're probably familiar with the idea that if you roll 2 dice, the most commonly rolled pair of numbers would be a 7. If we wanted to see this list sorted, we could do that. Roles.sort. And print the roles again. I kind of like seeing it like this because we can see that we only have 2 2s, but we had a whole bunch of 7s. And that's what we're going to see. Now let's create our histogram. Histogram. How many times was 2 rolled? How many times was 7? Etc. So what we're going to do is we're going to process through the list with a for loop. For x in roles. And then we're going to add that to the dictionary. And if it's the first time we find it in the dictionary, we're just going to set it equal to 1, right? Say we had a 6, but our dictionary is empty. We're going to check. Is 6 in the dictionary? No. Then set the histogram subscript 6 equal to 1 because it's the first time we've spotted it. Otherwise, we're going to take that value that is at that position in the histogram dictionary and then add 1 to it. So let's do for value, for die roll, for value in roles. Now we need our dictionary, and I forgot to create it here. So I'm just going to call it a hist, short for histogram. Hist equals DICT parentheses in parentheses. For every value in roles, if that value exists in it, if value in hist, colon, we're going to get that value and add 1 to it. Hist subscript value in subscript plus equals 1. Add 1 to the count. But if it's not in the histogram, if it's not in the dictionary, else colon we better set it equal to 1 so it'll be there next time we want it. Hist equals 1. Excuse me, hist subscript value in subscript equals 1. And then let's, in the short term, print our histogram out just to see what it looks like. We'll come up with a fancier way of printing it out. All right. I'll bring the text back up. But it's showing me that I rolled a 2 4 times, which if I come and look at the data, I see that's true. I rolled a 3 10 times. I rolled a 4 7 times. That's interesting. I rolled an 5 8 times. 7 22. And if we ran this again, we'd get different results each time. So let's pretty print it. Let's make it a little bit prettier. Since a dictionary is a pair of key and values, the key is the number that was rolled, and the value is how many times it was rolled. So for key in Hist, num rolled equals Hist subscript key. And then let's print a cute message. Print parentheses, quote, num rolled, comma, quote, was rolled, end quote, comma. Wait, I've messed that up and I'm deleting it entirely. Print parentheses, key, comma, quote, was rolled, end quote, comma, num rolled, comma, quote, times. Now that's a little bit too wordy, but it'll make it a little clear what we see here. Right, so 2 was rolled 2 times, 3 was rolled 5, 4 was rolled 9 times, and this is what's called a bell curve distribution. The middle has the largest numbers, and the ends have the smallest. We could even kind of try to print that out as a bar graph or something like that. This is really applicable to one of the projects, which is open up a file and to check for the letters in that file to see whether you had more A's or B's or C's or D's or whatever in it. So I'm hoping this part is really clear what's going on here. And let's create a second example using a string of text. All right, that's my string. Except I'm going to make it text. Histogram of letters in the text. Letter count equals empty dictionary. Curly brace in, curly brace. Which is the same thing as saying dict, parentheses 0, in parentheses. We're going to step through every letter in it. Maybe we ought to make it uppercase first, right? Text equals text.upper. That way we just won't count lowercase a as being different than uppercase a. And then for X in text, or for CH, I like using CH for characters, for CH in TEXT colon, we're going to check to see if it's in our dictionary, in our letter count dictionary. If CH in letter count colon, add 1 to it. Letter count subscript CH in subscript plus equals 1. Else it's not in there, so we better initialize it with to a value of 1. Else colon, letter count subscript CH in subscript equals 1. It's the first one we found. And now, just like we did with the numbers, let's print it out with a for loop. For letter and letter count, colon, print the letter, comma, and then letter count subscript letter. Like that. And so in that text, there were 3 I's, there were 6 spaces, there were 5 L's, there were 17 K's, and so on. Now we might want to make this sorted somehow. We might want to sort by key, we might want to sort by value. We could Google up how to sort a dictionary. gosh, I said that I was going to spend this lecture recapping the homework and instead I went off going lickety-split.
Oh, that reminds me. You never opened a Dropbox for assignment 15 at all.
That could be. All right, let's pause this. And so as a reminder for homework 15, it asks for things like how to add things to a list based on for loop or data entry or something. That's just doing something like this. Say we had a list and we initialized it to 0, then we had some kind of for loop that was going to put data into it. For I in range, up to 100, colon, L dot append I. That would create a list of all the numbers between 0 and 99. And if we needed to, instead, we could ask for a word, right? Rather than append I, we could ask for input and then use L dot append to put that input into the list. And really, that's the entirety of homework 15. It can be done using those two techniques. Okay, so I think I'm going to leave the homework as is rather than give us a new one. But you probably see, if you've read the projects and remember the one about word count and letter count, that this one is practically just about the answer to that project or half that project. We didn't show how to make a bargram. We didn't open a file. We didn't, divvy it with words. But you could use dot split to change a huge string of words into a list, and then you could process that list in the same fashion that we've been doing, which is what we did with the die rolls, right? We made a list of die rolls, and then we processed it as though it were a list. And then we did the same thing with a string. So if you read your text from a file, you could process it as a string to get all the letters, and then you could convert it to a list with dot split, and then process it item by item that way. Yeah, let's go ahead and stop. We'll make the Dropbox for that. And we can hang out and talk if anybody has any questions over homework previously assigned. Which I guess at this point is all of it, because I didn't give you any new.